Let's look at the different methods for solving quadratic equations. When we're solving quadratic equations, we want to make sure that we have exact answers unless we're asked to approximate them. Also, if we get answers that are not real, meaning we have a complex result, we need to make sure our answers are in standard form. And standard form is a plus bi. We'll see some examples later. We'll be looking at 4 main methods for solving quadratic equations: factoring, the square root property, completing the square, and the quadratic formula. Of the 4, 2 of them will always work on every quadratic equation we have. The 2 that always work are completing the square and the quadratic formula. Factoring is something that we learned first in our course, and we spent a lot of time in Chapter 14 working on refining our skills at factoring. Factoring does take a lot of number sense. Knowing how to factor a number, to break it down into prime factors, to find factors that are in common is an important skill for solving not just quadratic or polynomial equations, but also further on into trigonometry and calculus and being able to solve those. Factoring can be very quick if we recognize the factoring pattern, but a lot of times quadratic equations cannot be factored. Let's take a look at a few examples to solve by factoring. The first one, 4k squared plus 8k equals 0. We notice that the equation equals 0, which is what we must have when we're solving quadratic equations. On the left, all of the terms have k in them, so we have a common factor of k. We also have a common factor of 4. 4 and 8 have a common factor of 4. So we can factor out 4k, and then we need to figure out, if I factor out the 4k, I'm doing the distributive property in reverse. And I need to determine what do I multiply by 4k to get the terms that I started with. So what do I multiply 4k by to get 4k squared? I need another k. And what do I multiply 4k by to get 8k? If I already have a k, I don't need another one. 4 times 2 will give me 8. And so we have our factored form of 4k times k plus 2 equals 0. Once we have our factored form, we can set each of those factors equal to 0 and then solve for k. We get k equals 0 automatically just by setting that first k factor equal to 0. And then k plus 2 equal to 0, we can subtract 2 and get our second answer, k equals negative 2. I don't have to worry about setting the 4 equal to 0 because we know that 4 does not equal 0. That constant we can divide by 4 and it no longer influences the equation. It doesn't influence the equation solutions anyway, but dividing by 4 can get rid of it, or we can just ignore that constant. We just don't want to ignore the variable. Looking at number 2, z squared plus 8z plus 15 equals 0. Here we have a trinomial, 3-term polynomial. So we need to find 2 numbers that multiply to be 15 and add to be 8. We need to figure out how to break this polynomial in such a way that we get its factors. And since my a out front, that first coefficient is 1, I know my factors, my first terms in the factors will be z. And then finding 2 numbers that multiply to be 15 and add to be 8, 3 and 5 work. We can try factoring using the AC grouping method. We could use the box method or an area method to factor. But the idea is to figure out how to pull the factors apart so that if we try to multiply it back together, we will get what we started with. So we can check z times z is z squared, z times 5 is 5z plus 3z. 5z plus 3z is 8z. And then 3 times 5 is 15. And it works out. Again, for factoring, we need to set each one of the factors equal to 0 and then solve to get our two solutions. Notice that we will always have two solutions for these quadratic equations because of the degree on the polynomial. The highest exponent on the variable present is 2. So we should have two answers for our equation. Try number 3 on your own. There is one first crucial step that you need to make before you can start factoring. I hope you can see it. Remember that for all quadratic equations to start out, we need to make sure that they equal 0. The square root method is the second method that we learned about. We talked a little bit about it in chapter 17 and more in this chapter, chapter 18. The square root method only works in a very particular pattern. X squared equals a number, or x plus a number squared equals a number. Most quadratic equations are not written in those forms, which makes the square root method limited. But when they are written in those forms, the square root method serves for a fast way to solve. I'll leave number 4 for you to try on your own, and we'll do 5 and 6 together. For number 5, s minus 7 squared minus 9 equals 0. We need to get it into one of the forms above where it's something squared equals a number. And I can do that by adding 9 to both sides. So add 9. And we get s minus 7 squared equals 9. The next step for the square root method, once we have it set up in the special form that we need, we can square root both sides to get rid of that square. Square root, but when we introduce the square root on the right, we need to make sure that we include a plus minus. Because we are introducing it, we don't know if what's being squared is positive or negative. There are two possibilities there, so we want to make sure we catch both possibilities. And we end up with s minus 7 equals plus or minus square root 9. Oh, but the square root 9, we know what that is. 3. S minus 7 equals plus or minus 3. We can add 7 to both sides. And I'm writing this in a particular way. Since 7 only has one sign, I'm going to put it in front of the plus or minus. So we have s equals 7 plus or minus 3. This isn't quite there yet because I can add 3 or I can subtract 3 and I can get my actual numbers. 7 plus 3 is 10, 7 minus 3 is 4, and those two are my solutions for the problem in number 5. We can check 10 minus 7 is 3, 3 squared is 9, 9 minus 9 works out to 0, and plugging in 4, 4 minus 7 is negative 3, negative 3 squared will give me positive 9, 9 minus 9 again is 0. They work out. Considering number 6, we've got something squared here. We don't have an x term, again leading us to use that square root method. So the first step is to get the thing that's being squared by itself. So we'll start out and subtract 16 from both sides. I don't like that 3 in the front. Let's divide by 3 so that we make sure the only thing on the left side is something squared. Now that we have x squared equals negative 16 over 3, we can take the square root of both sides, plus or minus square root negative 16 over 3. And we can start to simplify this square root. We can clean it up a little bit so that it's in a form more recognizable. Plus or minus, I'm going to split that square root across the division. I'm allowed to do that by order of operations. The square root of 16 I know is 4, but I have a negative 1 there. Square root of -1 is I. Square root of 16 is 4. So I really have 4i up top over the square root of 3. And this could be an acceptable answer. I'm okay with that answer. But it could be necessary to rationalize the denominator. Rationalize the denominator means we don't want to have a square root in our denominator. So we need to multiply by a special form of 1 to get rid of that square root that's down there. Square root 3 times square root 3 would give me 3 on the bottom. I no longer have a square root. So I'm going to multiply by a special form of 1, square root 3 over square root 3. And on top, multiplying straight across, 4i square root 3 over 3. Here's an alternative answer. And I'm going to do that in a different color, mostly because it's not the second answer. The two answers are already encapsulated with that plus minus. So we have two answers present. The second way to write in the orange bubble is an alternative form. It's exactly equal to what we boxed in purple above. It just looks different. And I say this to also caution you to watch the instructions carefully in your homework. Make sure you're following the instructions so that you know how the answers should be entered. In the next lesson, we will look at solving the equations by completing the square and by the quadratic formula.